Okay, this is chapter 19.2, going over the quadratic formula. So the concepts we're going to look at today are the pretty much what is the quadratic formula. And what I'm going to do in that first concept is I'm going to show you a mathematical proof. And this is just for your own personal knowledge. This is not something that is going to be tested over. Then we're going to look at how to solve quadratic equations using the quadratic formula, how to use the quadratic formula in some applications, how to find the discriminant, and then just some mixed review using different methods with the quadratic equation. So concept one, we have the definition of the quadratic formula. It says for a quadratic equation of the form ax squared plus bx plus c equals 0, the solutions are always the quadratic equation here. So remember, we learned how to factor them, and when we factored some of them, we never labeled them as no solution, we labeled them as not factorable. Well, all those ones that we labeled as not factorable, we can now solve those using the quadratic equation. And that quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. This quadratic equation, every single time you use it, will give you the correct answer. Unlike factoring. Sometimes with factoring, we get something that's not factorable. That won't happen with the quadratic formula. Now let's look at a proof. How did these mathematicians figure out, this formula in the first place? Okay. And how they figured it out is they derived it from the quadratic equation. So remember, our quadratic equation is ax squared plus bx plus c equals 0. Okay. They want to see if they could get this in terms of just x. And so what they did first with this equation is that they divided everything by a. When they divided everything by a, the first a's canceled, so they're left with x squared plus b over ax plus c over a is equal to 0. Okay. Remember, a, b, c are just numbers. Okay. Then what they did is they subtracted that c over a over. So we had x squared plus b over ax is equal to negative c over a. Then what they did is they used the method of completing the square. So we talked about completing the square last time. And remember what completing the square was, is that we had the formula for our n value. I'm going to write this off to the side, that it was 1/2 b squared. So in this case, our b value is that b over a. So what they did is they did x squared plus b over ax plus 1/2 times b over a squared is equal to negative c over a. And remember, they had to add it over to the other side as well. So this right here, they did completing the square. Okay. When they did that, they noticed that once they simplify this, they were able to get x plus b over 2a squared, because remember that completing the square turns it into one factor, okay, is equal to, and then they simplify the other side, and when you simplify the other side, you get that b squared minus 4ac all over 4a squared. Notice how that b squared minus 4ac, that's starting to look somewhat like our formula. Then what they did, since that first side is being squared, they took the square root of both sides in order to get rid of that square. So they're left with x plus b over 2a is equal to the square root of b squared minus 4ac over the square root of 4a squared. Okay. The denominator could simplify because we know that the square root of 4 is 2 and the square root of a squared is a. So we had x plus b over 2a is equal to square root of b squared minus 4ac over 2a. Okay. Lastly, what they did is they subtracted that b over 2a to both sides. And they got x is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Where they just combined those fractions, got x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's how they proved that this would work. They took the original standard form for a quadratic equation, manipulated using rules that were already known to the mathematical world, and then they got the quadratic equation at the bottom. This is called a proof. Okay? This is not something you will ever see unless you choose to major in mathematics. Because then you'll see lots of proofs and you'll even take classes on just this, just proving a bunch of different concepts. Okay. I just think it's interesting. I just wanted to show you kind of what some of a more advanced math would look like. But the only thing you need to know from concept 1 is that this is the quadratic formula. Okay, let's look at concept 2 where we're using that quadratic formula. So remember, in order to use it, we need to start off with the standard form. And remember, standard form for a quadratic equation is ax squared plus bx plus c equals 0. Looking at this problem over here, notice that it's not equal to 0, it's equal to 5. So I'm going to have to move that 5 over in order to put it in standard form. So I'm left with 2x squared minus 3x minus 5 is equal to 0. Now that I have everything looking like standard form, I can label my a, b, and c value. So remember, a is always the value in front of x squared, b is the value in front of x, and c is that last value. Okay. See how I'm including those signs. Okay. Since that 3 was negative and the 5 was negative, my values for the b and c values have to be negative. Okay. So now I'm using the formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, we don't need to memorize that. You're going to have your notes on the test. Now we're just plugging in our values. So x is equal to negative b. So b is already negative. It's negative 3. So I'm going to do positive 3 because a negative and a negative is a positive. Plus or minus the square root of b squared, so negative 3 squared, minus 4 times a is 2, times c, negative 5, all over 2 times a, which is 2. Once I have everything plugged in, I'm now just simplifying. Okay, and you can do a lot of this on your calculator. So negative 3 squared I know is 9. Negative 4 times 2 times negative 5 is going to give me a positive 40. And 2 times 2 is 4. So far I have x is equal to 3 plus or minus the square root of 49 over 4. We know that the square root of 49 is 7. So we have x is equal to 3 plus or minus 7 over 4. That plus or minus sign tells you that there's two separate answers. So there's going to be one with the plus and one with the minus. So this becomes 3 plus 7 over 4 and 3 minus 7 over 4 to give us our two answers. So the top one is 10 over 4, which reduces to 5 over 2. And the next one, 3 minus 7, is negative 4 over 4, which simplifies to negative 1. So that means these are my two answers. I write them as a solution set of 5 over 2, comma, negative 1. Okay, that's my answer. And we would have found the same exact answer if we were to use the factoring method, AC method, and then factor by grouping. We would have got the same answer. This is just another way to get our solutions to these quadratic equations. Okay. Let's look at number 2. So again, number 2, it needs to be in standard form. Okay, and remember standard form is ax squared plus bx plus c equals 0. So in order to do that, we're going to have to distribute that negative x, and then we're going to have to move that 11 over. So I have negative x times x, which is negative x squared, negative x times negative 6, positive 6x equals 11. Now I'm subtracting that 11 over, and I get negative x squared plus 6x minus 11 equals 0. Okay. Remember, I don't like dealing with a negative in the a value. So what I'm going to do is I'm going to multiply this whole equation by negative 1, and that's just going to change the signs. So x squared minus 6x plus 11 equals 0. So labeling my a, b, and c, my a value is 1. My b value is negative 6, and my c value is positive 11. Okay. Writing my formula. And then now we're going to plug everything in. So x is equal to negative b. Our b is negative 6, so it's already negative, so now it's going to be a positive. So 6. Plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 11, all over 2 times a, so 2 times 1. Now I go through and simplify. Negative 6 squared is 36. Negative 4 times 1 times 11 is negative 44. 2 times 1 is 2. So I have x is equal to 6 plus or minus the square root of 36 minus 44, which gives us negative 8. Okay. All over 2. Remember, anytime we see the square root of a negative number, this tells us that we're going to have an imaginary number, I. Okay. So what we need to do here is we need to first reduce that radical, so the square root of 8, using the prime factor tree. So remember, 2 goes into 8 4 times, 2 goes into 4 2 times. So that means we circle a pair of 2's, and this square root of 8 is the same as saying 2 square roots of 2. Okay. So here we have x is equal to 6 plus or minus 2i, because we're taking out the I because of the negative, square roots of 2 over 2. Okay. Remember, this is the same as splitting it into two different answers, one with that plus, one with that minus. So 6 plus 2i square root of 2 over 2, and 6 minus 2i square root of 2 over 2. If we look at all of these terms here, notice how they can all be reduced by 2. Which means that 6 is now a 3, and all those 2's are now 1's. Okay. So that means we have 3 plus I square root of 2 over 1, which I don't need to write, and 3 minus I square root of 2 over 1, which again, I don't need to write. So I have the solution set of 3 plus I square root of 2 and 3 minus I square root of 2. And that's my answer. Okay, so this is two ways to use that quadratic formula. In the first way, this was something that could be factored. And we know that because we got two real answers. This is solving one that could not have been factored because we got two imaginary numbers. Now let's look at concept 3, some applications. It says a delivery truck travels south from Hartselle, Alabama to Birmingham, Alabama along Interstate 65. Okay. This information is not important to us. The truck then heads east to Atlanta, Georgia along Interstate 20. The distance from Birmingham to Atlanta is 8 miles less than twice the distance from Hartselle to Birmingham. That's important information. If the straight line distance from Hartselle to Atlanta is 165 miles, find the distance from Hartselle to Birmingham and from Birmingham to Atlanta. All of that is great information. And if they did not give us a diagram, we would have to interpret that information and create our own diagram. But they gave us the diagram for us. So there's no need to interpret that information. They have already set up this chart that shows the distance from each city that this delivery truck is traveling. And so notice that this looks like a right triangle. And since it is a right triangle, the first thing that should pop in your head is that, okay, I'm going to be using the Pythagorean theorem. Okay? Remember, the Pythagorean theorem is a squared plus b squared equals c squared. And the only important value that you need to remember is c. And c is always the diagonal. C is always the hypotenuse. So this is c. And then the other values don't matter. So this could be a, this could be v, or vice versa. Now let's plug everything in. A is x, so x squared plus b, which is 2x minus 8 squared, is equal to c, which is 165 squared. Okay, so x squared, that's just x squared. And that 2x minus 8 squared tells us that we're going to have to write these parentheses twice and use the FOIL method. And then 165 squared is, let's see, 27,225. Okay, so first we're using that FOIL method here. Okay, so we have x squared plus 2x times 2x is 4x squared. 2x times negative 8 is negative 16x. Negative 8 times 2x is negative 16x. Negative 8 times negative 8 is plus 64. Remember, this is all equal to that 27,225. So combining like terms, we have x squared and 4x squared, so 5x squared, negative 16x and negative 16x, which is negative 32x, plus 64 is equal to 27,225. Since we have this set up as a quadratic equation, we know that we now have to get everything to one side and set it equal to 0. So I'm going to be moving this 27,000 over. So I have 5x squared minus 32x minus 27,161 equals 0. That's me subtracting that number from 64. Now I can label every part, my A, B, and C value, and plug it into my quadratic equation. Now remember, this is a real-world application, so of course our numbers are not going to be perfect. We could end up with numbers that give us decimals or numbers that just couldn't be true. So plugging everything in, I get x is equal to negative b. Our b value is already negative, so this is going to be a positive 32, plus or minus the square root of b squared, so negative 32 squared, minus 4 times 5, because that's a, times c, which is that negative 27,161, all over 2 times a, so 2 times 5. Okay. Simplifying everything under that radical in your calculator, you're going to get x is equal to 32 plus or minus the square root of 554,244 all over 10. Okay. Which means we have our two possible answer choices. We have x is equal to 32 plus that square root over 10, and we would type that into our calculator, and we get x is approximately 76.97, and then we have the opposite one where we're subtracting, and then you type this into your calculator, and you would get approximately negative 70.57. Okay. Out of both of these answers, out of this positive 76 and this negative 70, this negative 70 is not possible because remember, x is representing a distance, okay? This x of a negative number is not possible because we can't have a negative distance, okay? So that means this x equal to 76.97 is representing the distance from Birmingham to Hartselle, because this was x. So this is 76.97 miles. Okay. But we still need to find the distance from Birmingham to Atlanta because that distance was not x. It was 2x minus 8. So kind of ran out of space here. Do it another color so we don't mix them up. So 2x minus 8 means I have 2 times 76.97 minus 8. And if I put that into the calculator, I get approximately 146 miles. So that means from Birmingham to Atlanta, that's 146 miles. And remember, this is estimating depending on the way you rounded. So you could have gotten 145 point something. And then those are the two answers it was looking for. Now let's look at the next type of example we would see using the quadratic formula. Number 4 says a toy rocket is launched straight upward from the side of a 144-foot cliff. Okay, we see that in the diagram here. Right here, here's our cliff. The initial velocity is 112 feet per second. The height of the rocket, h of t, is given by this function. Find the times at which the rocket is 208 feet above the ground. Okay, so 208 feet. Notice that the rocket is represented by that blue graph. So we need to find when it is 208 feet. So notice that crosses at 2 points. When it's getting launched up and then when it's getting launched down. We need to find those t values. So there's going to be 2 answers. Okay. So since this wants us to find when the rocket is 208 feet above the ground, that 208 is representing our h of t value. So that means we have h of t is equal to negative 16t squared plus 112t plus 144. Our h of t is 208 is equal to all of this. And in order to use our quadratic formula, we have to have it equal to 0. So I'm going to subtract 208 to the other side. And I'm left with 0 is equal to negative 16t squared plus 112t minus 64. Okay. Looking at this, before I can even solve, I notice that I can take out a GCF of negative 16. So I'm going to take out that negative 16, and I'm left with t squared minus 7t plus 4, and then, of course, that's equal to 0. So now I'm only looking at this function inside the parentheses. So then I have my a value, my b value, and my c value that I'm going to be plugging into my quadratic equation. Okay, so that means I have x is equal to negative b. B is already negative, so I'm going to do positive 7 plus or minus the square root of b squared, so negative 7 squared, minus 4 times a, which is 1, times c, which is 4, all over 2 times 1, so that's 2a. Simplifying the radical part, I get x is equal to 7 plus or minus the square root of 33 over 2. Okay, which means I have 7 plus the square root of 33 over 2 and 7 minus the square root of 33 over 2. Plugging that into my calculator, I get approximately 6.37 and approximately 0.63. So this tells me that at the first 0.63 seconds, I reached 208 feet, and then at 6 seconds, 6.37 seconds, I reached the second distance of 208 feet. So right here, 0.63, 6.37. So I have t is equal to 0.63 seconds, and t is equal to 6.37 seconds. And that's my answer. In this next concept, we're going to be looking at the definition of a discriminant. Give me one moment. So the discriminant of a quadratic equation is the part that is under the radical. So if we had the equation x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a, the discriminant is just this part, b squared minus 4ac. And the reason why this discriminant is important is because it can help us determine the number and type of solutions to the quadratic equation. And for example, if our discriminant is greater than 0, so if it's positive, we will have two real solutions. Okay. If it's positive and it's a perfect square, it will be two real rational numbers. If it's not a perfect square, then it will be two real irrational numbers. If our discriminant is negative, we'll have two imaginary numbers. And if our discriminant equals 0, we'll only have one real rational solution. So this is a good chart to have with you on the test. Okay. So again, we're only finding the discriminant. And remember, the discriminant is just that b squared minus 4ac. So first, we're checking to make sure this is in standard form. And if it's in standard form, we're labeling our a, b, and c. So we have a, b, and c. So plugging that in, b squared, that's negative 5 squared, minus 4 times a, which is 2, times c, which is 9. So we have 25, and then negative 4 times 2 times 9 is negative 72, which gives us a negative 47. So since we got a negative discriminant, which means that negative 47 is less than 0, that tells us that our two solutions are going to be imaginary. So we have two imaginary solutions. Number 6, before we can label our A, B, and C, we have to make sure everything is in the correct order according to our standard form. So I'm going to have to add the x and subtract the 2. So I have 3x squared plus x minus 2 equals 0. Label my A, B, and C. So this one I don't have a number, so I assume it's 1. See? And then my equation, b squared minus 4ac. I plug everything in. So b squared, so that's 1 squared, minus 4 times a, which is 3, times c, which is negative 2. So 1 squared is 1. And negative 4 times 3 times 2 is a positive 24. So I get 25. Okay. Since 25 is a perfect square, which means I can take the square root of 25 and I'm going to get a perfect number of 5. Not only do I have two real solutions, I have two real rational solutions. So I have two real rational solutions. And again, this is because this is a perfect square. I can take the square root of it. Okay, let's look at number 7. Remember, I need to have it in standard form first. So I'm going to distribute this negative 2x, and I get negative 4x squared plus 6x equals negative 1. I'm going to move that negative 1 over. So I get negative 4x squared plus 6x plus 1 equals 0. And just because we're finding the discriminant, I'm going to go ahead and leave that negative in front of my a value. So this is going to be A, B, and C. So I have B squared, so 6 squared, minus 4 times A, which is -4, times C, which is 1. I get 36 from 6 squared, and then -4 times -4 times 1 is a positive 16. So 36 and 15 gives me 52. 52 is a positive number. However, it is not a perfect square. So not only am I having two real solutions, I'm having two real irrational solutions. And again, this is because it's not a perfect square. You can't take the square root of 52 and get a solid number. Okay. Number 8, we have our equation here. And notice again, this is not in standard form. So I'm going to add that 1.2x over and add that 0.1 over. So I have 3.6x squared plus 1.2x plus 0.1 equals 0. So that means this is my A value, B value, C value. And I'm going to plug it into my discriminant. B squared is 1.2 squared minus 4 times A, which is 3.6, times C, which is 0.1. 1.2 squared is 1.44. -4 times 3.6 times 0.1 is a -1.44. So we have a positive 1.44, a negative 1.44. So if we put those together, we get 0. And remember, if we get 0, that means our answer is going to be one rational solution. Okay. Number 9 gives us an equation and it says find the discriminant. So that's the first thing we're going to do. So we have that b squared minus 4ac. Our a is 1 because we don't see anything. B is -3. C is that 1. So I have b squared, so -3 squared, minus 4 times a, which is 1, times c, which is 1. So this gives me 9 minus 4. Make sure I plugged in my numbers good. Yeah. 9 minus 4, which is 5. Okay. That 5, since it is positive, tells me I'm going to have two real solutions. But since it's not a perfect square, it's going to be two real irrational solutions. Okay, then it says find the x-intercepts. So remember, the x-intercepts can be found when y is equal to 0, and the y-intercepts can be found when x is equal to 0. So in this part, if y is equal to 0, that means we're going to be using the quadratic equation. So x is equal to -b plus or minus the square root of b squared minus 4ac over 2a. Notice we already found that discriminant part, that part under the radical. So this is x is equal to -b. B is already negative, so 3, plus or minus the square root of 5, because we already found it over here, all over 2a, so 2. Meaning we have two answers here for our x-intercepts, and that is when one is positive and one is negative. So we have the answer of 3 plus the square root of 5 over 2 comma 0, and 3 minus the square root of 5 over 2 comma 0. So remember, our x-intercepts are always a number, comma 0. Our y-intercepts is when x is equal to 0. So we're just going to plug in 0 for x. So f of 0 is equal to 0 squared minus 3 times 0 plus 1. These all cancel, and I'm left with 1. So that means my point is 0, comma 1. This is my y-intercept because it's always 0, comma a number. So here are all of my answers here. Okay. Let's look at number 10. Same thing, it wants us to first find the discriminant. So b squared minus 4ac. So I have a is 1, b is also 1, and c is 2. So I have b squared, so 1 squared, minus 4 times a, which is 1, times c, which is 2. So this is 1 minus 8, which is negative 7. Remember that negative 7 tells us that we're going to have an imaginary solution. And when we have an imaginary solution, that means there are no x-intercepts. So we would write do not exist. However, there's still a y-intercept. And remember, for y-intercept, we plug in 0 for x. So f of 0 is equal to 0 squared plus 0 plus 2. These cancels out, and we are left with the point 0, comma 2, which is our y-intercept because it's always 0, comma a number. So that means our answers here are that negative 7, which tells us there's an imaginary solution. That imaginary solution tells us our x-intercepts do not exist. And our y-intercept when we plug in 0 is 0, comma 2. Okay. Now let's look at some mixed review, meaning we can use any method we want to solve these quadratic equations. We could use the AC method and the factor by grouping. We could use the trial and error method. We could use the quadratic equation. Completely up to you. Since this is practicing using the quadratic equation, I'm just going to use the quadratic equation for each one. So remember, before we do that, we need to make sure it's in standard form. So this x plus 3 squared tells us we write it twice in FOIL. And then bring down that x squared minus 9x equals 8. So if I FOIL this, I'm left with x squared plus 3x plus 9. Bring down that plus x squared minus 9x equals 8. Okay. I'm going to move this 8 over to the other side by subtracting it, and then I'm going to combine all these like terms. So I have an x squared, a 3x, and a negative 9x, and a 9 and a negative 8. So I have 2x squared, 3x and 3x is 6x, 6 minus 9 is negative 3x, 9 minus 8 is 1. Okay. From here, I want you to go ahead and use the quadratic formula. And if you did it correctly, you should get x is equal to 1/2 and x is equal to 1. Okay. So I got it all into standard form for you. use the quadratic equation to solve. Okay. For number 12, remember we need to have it in standard form, so we're going to move this part over. So I have x squared minus 2x plus 5 equals 0. Remember, I put it into that standard form. Okay. Your a value is 1, b value is -2, c value is 5. So plugging it into our formula, we get x is equal to -b. b is already negative, so we'll just write a +2, plus or minus the square root of b squared, so -2 squared, minus 4 times a, which is 1, times c, which is 5, all over 2 times 1. Okay. This is going to give us x is equal to 2 plus or minus, once we simplify that discriminant, we get, so that this becomes a 4, and this becomes a -20, so -16, so square root of -16 over 2. Okay. Square root of 16 we know is 4, but since it's a negative, this is going to be 4i. So I have x is equal to 2 plus or minus 4i over 2. We can again simplify all these by dividing it by 2, and we're left with 1 plus or minus 2i. Okay. Which means our two answers is x is equal to 1 plus 2i or x is equal to 1 minus 2i. Number 13, before we solve any of this, we need to get rid of the fractions. And remember, we get rid of the fractions by looking at the common denominator. So we have a 4, a 2, and a 3. So the common denominator between all of those would be a 12. So I'm going to multiply this whole equation by 12. So I have 12 fourths x squared minus 12 halves x plus 12 over 3 equals 0. These each now simplify to a solid number. 12 fourths is 3, so 3x squared. 12 halves is 6, so minus 6x. And 12 thirds is 4, so plus 4 equals 0. Now that I got rid of the fractions, I know that my a is 3, my b is -6, and my 4 is that c value. So go ahead and plug it into the quadratic formula. And if you did it correctly, you should get, let's see, you should get x is equal to 3 plus or minus this I square roots of 3 over 3. And remember, you could write that as two answers or keep it together. Okay, so self-practice, you should get that answer. Okay, and then last one, number 14. Okay, remember we have to have it in standard form, and that standard form is the ax squared plus bx plus c equals 0. From here, it looks like we're missing a b value. So since we're missing that b value, we could assume that b is 0. So we have 9p squared plus 0b minus 11, or sorry, not 0b, the variable's p, plus 0p minus 11 equals 0. So that means our A value is 9, our B value is 0, and our C value is that negative 11. Okay. So for this one, go ahead and try using that quadratic formula. And if you did it correctly, you should get your answer to be x is equal to plus or minus the square root of 11 over 3.